Okay, this is all about long division and the quotient remainder theorem. So let me just remind you a little bit about the quotient remainder theorem. That I have, I get two positive whole numbers. I'm going to call them A and K. All right. And remember, what you're doing is you're trying to come up with A div K is some quotient remainder R. Okay. And so what this says, there's unique numbers Q and R such that this is true. And all you get from this is just rearranging this, right? So this rearrange gives me that. And then what you want, and then the key thing about this, there's two key things with this. One says unique here. That means if I have A and K, I have there's only one answer for a pair, A and Q and R. And R has to be between 0 and the divisor, okay, but not including the divisor. It can be 0. Right. So this is, again, if I'm doing, say, 30 div 4, which is 7 remainder 2, right? Right. This is just this rearranged. 30 is 4 times 7, 28 plus 2, and we've got that. All right, so that was just a reminder of this. Now, I want to do is tie this into long division. So let's do 3742, for example. And that looks more like an S than a 5, so let's make that a 5. Okay, let's just remember what it is that we do for long division. 5, I'm going to try to divide into 3. Okay, but it's smaller than 5. So I'm going to walk to the next one, is 37. So that pair, right? And so 7 times 5 is 35. And I subtract, I get 2. So what did I just do there? I just did 37 div 5 is 7 remainder 2. So what do you see there? That's really a Q sitting right there, and that right there is my little R. Okay, so the first step, right, all we're doing is using the quotient remainder theorem to get that. Okay. I'm going to drop down the 4. 5 to 24 will go 4 times. 4 times 5 is 20. And then subtract. So what did I just do there? I did 27 divided by 5 is 4 remainder 4. Okay. And then bring the 2 down. Okay. And I'm doing 8. 8 times 5 is 40, and I get 2. So my last one here is 42 div 5 is 8 remainder 2. All right. Good. All right, so all we've done is this is 3 steps of this, which is really just the quotient remainder theorem. Right? And on each step, this is my Q. So those are all my Q's. And then my R's are those 3 remainders. All right. So in many ways, what long division is, talked about it in the previous video, is a way to think about the chip model for multiplication in reverse. Another way to start thinking about it is it's really just the quotient remainder theorem with some place values here, right? Because what you're doing is this 37 really implies it's 3700, right? And so that 7 represents 700, if that makes sense. Right? And that 4 represents 40, right? And that represents 240. And you can fill all these things in as zeros if you want to do that. I find it clutters things up, but if it's clarifying to you, it's totally fine. Okay. All right, let me do one other example. There's one other important thing that I didn't talk about with this. And then let's do 8. Let's say 8 into 5392. Okay. So 8 can't go into 5. So 8 will go into 52, and there's 6 times, right? 6 times 48. And I get a 5. And bring down the 9. Okay, so again, a Q of 5, let's just write that down again. 53 div 8 was 6 remainder 5. Okay. Now, let's just do the same thing. It's like, oh, well, 59 is almost 53. This is probably 6 again. So let's try 6 there and do 48. And I subtract and I get an 11. Okay. Right, and this is supposed to be the remainder. So that's supposed to be the remainder. So what does that mean? Well, this is the other key piece of this, right? The remainder R is always between it can be equal to 0 and up to but not including the divisor, which is 8. There's the divisor there, right? So this is too large. Right? So from QR, R is too big. Okay? What that means is this is like a little sanity check to go, oh, wait a second. Okay, if it's too big, this was not right. So and then instead, that's going to be a 7. I'm going to squeeze this in here. 7 times 8 is 56, and I get 3. And by the way, notice that this remainder is now 8 less than it was before. That's not a coincidence either. And then let's finish this off. 832. Oh, 4. Wow, look at that. And 0. So I did a remainder 0. And remember, you can. So now here's those are my remainders. I've got 5, 3, and 0. And 0 can be a remainder, right? Because it's less than or equal to 0. But strictly less than k, which is 8 in this case. All right. So basically what this shows is really long division is really just kind of an application of the quotient remainder theorem. It also uses some sanity checks in there to go, oh, I'm on the right track. Okay. This kind of thing doesn't prevent all errors. You could still make multiplication errors or subtraction errors, but other than that, it's going to like tip you off to making sure that you're getting at least the right numbers up here, so on. So, all right. So that wraps up long division with the quotient remainder theorem.